So in today's experiment, we're going to be combining a variety of solutions which contain ionic compounds. Most ionic compounds are very soluble in water. Water is a really good environment for ionic compounds, and so most ionic compounds do in fact dissolve in water. On the other hand, there are some ionic compounds that do not dissolve well in water. And whenever those ions run into each other in solution, they go back to being solids. That is, they form precipitates. So in this experiment, we're going to be combining a variety of solutions which contain metal cations and a variety of solutions which contain anions. And see what happens when we mix those two solutions together. That is, what happens when that cation and that anion come together. If they form a soluble compound, nothing will happen when we mix the solutions. But if they form an insoluble compound, then you'll get a precipitate. The solution will become cloudy and you can't see through it. That's because you're forming a solid. If a solid forms, and you know what the cation and anion that make that compound up, you should be able to write out the formula of that compound, keeping in mind that it has to be the fewest ions that give you something neutral. In order to do today's experiment, you're going to need to set up a data sheet that looks like this, with the cations down one side and the anions across the top. And then as you combine those two solutions together, you should record what you observe to be the effect. Like you said, we're basically looking for precipitates. Precipitate means you formed a solid. The way you can tell you formed a solid is the solution will become cloudy and you won't be able to see through it. That means you have a precipitate in it. So that's what you're looking for. Does the solution become cloudy and can you no longer see through? So we have our 6 solutions of our anions. Now we'll add a solution that includes silver plus 1 cations to each of these test tubes and see what happens. Stir each of the solutions, give them all a chance to react. And so there's the result of silver ions with each of those anions in aqueous solution. Again, we have our 6 anions set up in their respective test tubes. This time we're going to add a solution of potassium ions to each of our test tubes. And that is our result
potassium ions in each of our anions in solution. Now we're going to try a solution that includes barium plus 2 cations with each of our anion solutions. And there's the result of barium ions with each of our anions in solution. Now we're going to try each of our 6 anion solutions with a copper plus 2 ion solution. So there is the result of copper plus 2 cations with each of our 6 anion solutions. This time we're going to be adding lead plus 2 ion solution to each of our anion solutions and see what happens. So there's the result of lead plus 2 ions with each of our anion solutions. This time we're going to try adding aluminum ions to each of our anion solutions and see what happens. And that is the result of aluminum plus 3 ions with each of our anions in aqueous solution.
That concludes today's experiment. You've seen what all the cations do with all of the anions and whether they form precipitates or not. For the solutions where you got precipitates, you have to take that cation and that anion and tell me what the formula of the compound you created that was the precipitate for each of the precipitates. Okay, and that's it for today.